Hello. I'd like to take the time to demonstrate how to do the correlation coefficient and then also how to calculate the linear regression line. Now, once you have your calculator on, you actually need to program it so that it includes the R, which is the correlation coefficient. So if you've already done this, then there's no need to do it more than once, because once it's been activated, it's no longer needed. So we go to second catalog, and we can either scroll down or we can just push the corresponding letter. So I'm looking for diagnostic on, so I'm just going to click D. So this allows me to go ahead and just kind of scroll a little bit more, and I want diagnostic on. Now what this does is it initiates the calculator and letting it know that we're going to calculate the correlation coefficient and also the linear regression line. So we just push enter and it says done. Okay. Now once we do that, let's say that we wanted to calculate a correlation coefficient, of which we can just go to stat and then go to edit, and then from here we can actually just go ahead and input our data. Now I'm actually just going to choose the example that we did in class about the hours per week of student studies. So we have 6, 4, 1, 2, and 3, and then from there we have that we're going to use 3.5, 2.5, 2, 2, and then 3. Now in this case we can actually just go ahead and just quit to the home menu, and from here we're just going to calculate the linear regression line and the correlation coefficient. So just click stat, go to calc, and you're going to select the lin reg. Now most likely if your calculator is an 83 or just the regular 84, you're just going to get the command that says lin regression ax plus b, which in either case you're just going to put L1 comma L2. But for us we have that. Now if I want to, I can actually store the linear regression line into the calculator, so that way if I want to find a particular estimated value, I just simply go to that. And I'm actually going to do that. So let's go to vars, and I'm going to select y variable, and then I'm going to select the function, and I'm just going to select one of these. For simplicity, I'll just choose y1. Okay, so again, this is just storing the equation into here so that, if you want to see it, the plot of it, you can. Now, not sure actually how this would work for particular older calculators, but that's one thing that is actually useful about this program, that it has kind of like everything. So we just click enter, and it tells us that the linear regression line is 0.297x plus 1.649 with a correlation coefficient of 0.877. Now if we go ahead and we look back at our lecture notes in class, we see that this was the table that we created for calculating the correlation coefficient. As you can see, there's a lot of things going on in order to get these computations, and we end up getting the exact same thing once we plug in everything. Once we take that 3.508 divided by 5 minus 1, because we're using the formula, that gives us 0.877 as a correlation coefficient. Now unfortunately though, this actually implies, if we use the appendix that shows us if there is a correlation between the two, we're actually going to find that there's not. And that's just because based on the table, in your appendix, it shows that with 5 sample, that it needs to be higher than 0.877 to be a higher correlation. Now, that doesn't mean that we can't, view the prediction line. It just means that it's not really going to be necessarily uh, uh, fruitful in the sense that, okay, yeah, if we know how many hours that you might study, does that really determine your GPA and things like that? So if we look at the y equals, where the graphing section is, you'll see that the equation actually has been written in there. So go to there, and you'll see all this nasty change. Well, that's totally fine, because notice that if we go to graph, there's our linear equation. Now, if we want to find, let's say, for example, a particular estimate, we can just go to second trace and select value, and then let's just say that we plug in 2. Now that gives us 2.24, which accordingly we have that was that was a GPA of 2, so there is a little bit of error, but that's kind of expected if we were to actually look at the stat plot of those data points.